Hey boys, you think you can help me with my friend's death?
What's up, Agent Hammy?
What's the matter?
My friend, Dr. Boylin, he's dead. I want you to figure out exactly when he was killed.
We're on it.
I got it.
Thank you.
Okay, so here's what we know. We know that the coroner's office is always kept at a constant of 17 degrees Celsius, and that's going to be useful in our equation.
And in the storyline, Boylin's body temperature was checked, and initially it was 27 degrees, which is also useful for our equation. And this is 10 degrees below normal, so normally it should be 37 degrees Celsius. But after an hour of the thermometer being in his body, Boylin's body temperature dropped to 24 degrees Celsius.
You know, when Agent Hammy found the body, she hit the security alarm at 5:12, and that's gonna be like used to figure out the exact time of death.
It's Newton's law of cooling, and we can use it to find the temperature of an object at a given time. All you do is get the initial temperature minus the temperature of the room that it's in, times Euler's number to the power of the cooling constant, times time, plus the temperature of the room. With this formula, we plugged in everything we knew. 27 degrees Celsius being the initial temperature when the body was first found, minus the temperature of the room, which was 17, times Euler's number to the power of K times 1, 1 being the time passed, and then plus 17 degrees Celsius, which is the room temperature. And we know that after 1 hour has passed, the body has cooled down to 24 degrees Celsius. Using the equation with everything that we know in it, all we had to do was solve for the cooling constant, because that was our only unknown variable. And doing that, we got to get K by itself, so we brought these together, 10 degrees Celsius, brought it all down, and then subtract 17 degrees Celsius, we just balanced it, and then divided by 10 degrees Celsius on each side. So that's 7 over 10 degrees Celsius equals Euler's number to the power of K times 1. And then we use the inverse property to get ln 7 over 10 degrees Celsius equals K times 1, which if we divided it, it would just be the same. After we figured out K, which is the cooling constant associated with human flesh, we needed to know how long ago he died. So from the time that he died to the time his body was found, his body cooled down to 27 degrees Celsius, which is 10 degrees below normal. So initially his body should be 37 degrees Celsius, minus the temperature of the room, which is 17, times Euler's number to the power of L, the cooling constant, times time, plus 17 degrees.
And we just simplified that equation. We need to get time alone, so we did 37 minus 17, and we brought everything down. Then we still need to get time alone, so we subtracted both sides by 17, and we got this. And here, we divided everything by 20, and then we got this. And here, we use the inverse property. And then we still have time over here with this. So we divided everything by ln of 7/10. And then we got this number, and this is our final answer. It's 1.9433 hours.
Now that we know that he died 1.9433 hours ago, we can multiply that number by 60 minutes to get how many minutes ago he died, and we got 116.6 minutes ago.
And we know that the alarm was hit at 5:12, and 116 minutes ago, it was 3:15.
Here we graphed the equation we had to figure out how much time had passed since his death. We also know we had to graph the temperature at this time to equal 27 degrees Celsius, because that's the temperature of his body after however many hours had passed.
The point of intersection tells us how many hours had passed for the body temperature to equal 27 degrees Celsius. He was killed at 3:15, so we can rule out anybody who wasn't in the building at 3:15.
So we know that Kyle left the building at 2:48, so it isn't her. Alyssa left at 2:51, so it wasn't her. Megan left at 3:10, so it wasn't her. But Sarah didn't enter the building until 3:40, which means that there was no one in the building from 3:10 to 3:40.
But there was somebody.
Who?
Sergeant Suspense.